Edexcel Core Pure, complex number 6, the exponential form. Expressing sine theta and cos theta in terms of complex numbers. If we consider z equals x plus iy in its component form, then we can use the exponential form to show that this very useful result is true. So if z is x plus iy, then e to the z is e to the x plus iy, as you would expect. Then using laws of indices, you can write this as e to the x times e to the iy. So e to the z can be written as e to the x, and e to the iy is the exponent form of a complex number, which can be written as cos y plus I sine y. We've previously seen that r cos theta minus I sine theta can be written in a different form, noting that the minus sign here is not part of the convention used in modulus argument form, so we need to exploit the fact that cos theta can be written as cos minus theta, and more significantly minus sine theta can be written as the sine of minus theta. So it's using these two together that have turned this into the correct modulus argument form with a plus sign. Now we have the correct modulus argument form, we can turn it into the correct exponential form. So that is telling me that r cos theta minus I sine theta can be written as r e to the minus I theta when necessary. So, using the result we've just discussed and the exponential form we've just found, now look what happens if we consider e to the I theta plus e to the minus I sine theta. So we've written each of these exponentials in its modulus argument form. Noting the minus sign on this one, the I sine theta cancels out and we're left with 2 cos theta. So if we make cos theta the subject, we can see and use the fact that cos theta is a half of e to the I theta plus e to the minus I theta. And this is very similar to the result for hyperbolic function cos theta, and this little derivation is well worth learning, ready to be used when necessary. Likewise, we're going to use these two again, but this time we're going to consider e to the I theta minus e to the minus I theta. So we've turned that exponential form into modulus argument form, we've turned this one into modulus argument form, and this time it's the cos theta that cancels out, and we're left with 2i sine theta. Hence, sine theta can be expressed as 1 over 2i e to the I theta minus e to the minus I theta. Notice a couple of things. Notice the minus sign in there, and notice it's 1 over 2i. And again, this is very similar to the hyperbolic definition of shine, and again the proof is well worth learning. So this definition of cos theta and this definition of sine theta are going to be extremely useful to us, and the proofs are worth learning, and being able to recall these and use them as required will be very beneficial. Do notice the 2i in the denominator of this definition for sine theta. In the next video we're going to be using the exponential forms of sine theta and cos theta.